you the real time reporting, and it provides you the long term analysis of security events. For example, you can save these events for 6 months and you can study it then, or you can read it then, or you can analyze it then. So that's the reason it is called long term security event. So I told you that the one which will be using is the ELK. However, worldwide, the SolarWind and Splunk is used in many of the organizations, but the one which is in free, which is open source, is the ELK, right? So, gentlemen, for what purpose we can use this? Okay, for what purpose I opened this Facebook basically. I showed you, or I sent you, for example, some of the jobs few days back. I hope you have seen them. And if you can see them, gentlemen, that is about somewhat similar. Yeah, what he's saying, digital forensic. So they want an assistant manager, which is an expert of the digital forensic. So what mean by digital forensic, or what mean by penetration testing, what mean by a network security SOC analyst. So basically all of these jobs are related to the work which we are doing. And you can see that with just some degree and like BS degree which you already have, and some of the certifications, you can be you can get such a job for around good salary. Okay, so gentlemen, what I want to show you is what mean by a digital forensic. Tabish, will you please close your mic? Hello, Tabish. Will you please mute your mic? Okay, probably not here.
Sir, maybe he's busy.
He might be busy. Anyhow, we continue, and when he will be back, okay, he did it now. So, gentlemen, digital forensic means that whenever some cyber crime occurs, so it is, I can say it is like, for example, whenever some crime occurs, the job of the police is then to gather some of the evidences which they present in the court of law, and based upon these evidences, the person who have done this crime is given some punishment by the court. Similarly, the other type of crimes are nowadays are the cyber crimes. In the cyber crimes, which maybe have even more influence as compared to the crimes which we normally say every day, because there is a dark web where even the people are available who can kill others, or which where the smuggling can be done, or where the money can be transferred, and many things can be done. So for to grab them, the people like you, which works like a digital forensic analyst, they captures or they record the, or they gather the evidences. So from where you will get the evidences, the SIM will collect the will get the all these will get the, or will store the logs, and people like you will read these logs, and will for what is the objective of the to study these logs, to get the evidences, what has happened, who is the source, who is the whether after getting the this source, the user, which means the attacker, what other resources he has captured as well, or what other task he has done. So you have to gather the information, complete information about everything like this. So this is called digital forensic analysis. This is a complete science. Then, gentlemen, I will give you the idea what is the other job, which is the correlation and aggregation, but reporting in that. What mean by a correlation? If you know, gentlemen, you have studied a chapter, or a complete topic or a complete subject on statistics or probability. where we have studied this correlation. Correlation means the which are related to one another. So if the, for example, the cyber the bad guy, the threat actor, when he attack, so he may attack multiple machines. So your SIM is a single machine where you are gathering everything. So multiple things may happen, may be there, which are correlated to one another, which means which are similar to one another. So the SIM, this ELK, this Splunk, this SolarWind, this, which means the security information and event management technology, that will correlate these events and tell you that what has happened. Then there are certain things which are duplicated, so you are wasting your time. So it will remove the duplicate event records to reduce the volume of your event data. And then finally it reports you can report your data to your boss, or you can report your data to some agencies which are there. So basically the job of this essential function, may I say, of the same are digital. It may be used for digital forensic, it may be used for correlation, it may be used for aggregation, it may be used for reporting, and these are the very, very important tasks. Okay, nice. No problem, Tabish. Okay, so Banori, did you got my points? Forensic, correlation, aggregation, reporting. So SIM is used for this purpose. And nowadays SIM has become very much advanced, because they are using the AI techniques, and with the AI you can make them more intelligent, or artificial intelligence. As we know, AI means artificial intelligence. So with this you can do in a better way the digital forensic, correlation, reporting, and everything. Okay, so SIM-U provides details on the source of why we are doing this monitoring. We want to know about the suspicious activities. Who is doing this suspicious activities? Definitely the threat actor, right? So what we want to know about this? We want to find the username, such as what is the username of that person, what is the authentication status, whether it is a authenticated user, what is the look or not, or he has used some tools, and because of this, for example, he has the password brokers, and through which he got authenticated, for example, where he's located, device information. You may want to know that what is the operating system, what is the MAC address, what is the network address, and all of these informations are important for us. Now, gentlemen, the newer technology as compared to the same is SOAR, which stands for, it is may I say, SOAR is enhanced SIM, enhanced, more powerful SIM, has been given the name of SOAR. So SOAR stands for security orchestration, and the important thing is automation, which is not in the SIM. That's the reason we call it a enhanced SIM. So SOAR helps security team, which means the SOC people. SOC means Banori, Security Operations Center. So in the people which are the security professionals, tier 1, tier 2, tier 3, if you remember. So these people who form a team, security team. So what is their job? Investigate the security incidents and add enhanced data gathering and a number of functionalities that add in security incident response. So we will be although the SOC people may be working as a incident response team or not, but incident response team, the job may also be done by the SOC people, maybe. But if it is a large organization, then SOC people are different and the incident response team is different. What is the job of this incident response team? Its job is when the incident occurs, how we will give you response. जैसे मैं हमेशा आप लोगों को कहता होता हूं, for example, okay, normally I give you an example that, for example, when some attack occurs on your school, college, university, wherever, so your police, your army, your other agencies, they respond then. And what is their response? To capture the people who have done the wrongdoings. So definitely here, when the threat actor attack your network, or definitely he will, when he will attack, he will do something bad for you, but you have to respond then. You have to stop him. You have to restore your everything. You have to inform your big box management. You have to keep your customers satisfied as well. So this is all comes under the security incident response. We will talk about them later, but just you should know that this is also a task which is normally performed by the security people. Make sense, Mohammed Ali, Banori? So the very important task is here is the automation, and that is done mostly through the using the AI, artificial intelligence, right? So we add AI methods in the same, may I say, and it becomes the SOAR, security orchestration, which means classification, automation, and response. So response is also there, that this device can help you to respond to the security incidents. So this is something good. So source solutions provide case management tool. Which means this is a tool that allows cybersecurity professionals to research and investigate incidents. Which means when an accident occurred, SIEM also give you the same choice, that you investigate what happened, where happened, what is the consequence of this attack, right? Who did it, right? Frequently by integrating, so the how it automates, it is integrating with the threat intelligence, live threat intelligence systems. What do you mean by threat intelligence systems, gentlemen? It means that in the world there are numerous international sources which are available, where they update regularly. So whenever some accident occurs, so this information is updated in these threat intelligence systems. Cisco also has a threat intelligence system. So this SOAR is directly connected to these threat intelligence systems, and it updates itself. So the new, even the old as well as the newer attacks, you are safe from it because your SOAR is updated, and it has the capabilities to learn, because it has the artificial intelligence embedded in it. So it is a very powerful, as it is written here, gentlemen, you can see it uses threat intelligence to detect incidents. So it means it is like a person, human, because human has the natural intelligence and it has the artificial intelligence, right? That adds in incident analysis and response. So it has two tasks, analysis and response. And how it will respond? Because it has the intelligence. What type of intelligence? Artificial intelligence. I hope you understand about, about the AI. Okay. So it automate complex incident response procedures and investigations, which are potentially labor intensive tasks performed by the SOC staff by executing run books. What do you mean by a run book? Gentlemen, the procedures. Run book is maybe an e-book or maybe a physical book where the procedures are written, which are used to respond to any incidents, which are maybe are called as the playbook. So this run book, always your company will have a run book which have the procedures, how you will respond or how you will analyze. So these methods are documented. So it uses these documented methods or documented procedures, and based upon this, it respond, it investigates. So normally, that these algorithms are quite heavy, but if it is done by a human, but when it is done by a computer, it becomes simple, it becomes fast, and it becomes error prone, because a human may do some error, but machine has a algorithm, and if the algorithm is good, which is definitely we assume that it is good, so our system becomes even good. So SOAR helps analysts respond to the threats. How to respond to the threats? It investigates and it respond. How? By using two things: automation through AI and connectivity to the live threat intelligence systems. Threat intelligence systems. Does it make sense, gentlemen? So I gave you the example of just a few minutes prior, that one which we will be using as the SIEM system, which is an open source, and it is called the Security Onion. So I will provide you the image of the Security Onion, and you will install it, and then we'll be using it, and we'll be using it a lot, because it is very important, right? Because SIEM, as you say, we have just seen that it is not only used by the security analyst, but it is used by the digital forensic people as well, for reporting, for investigating, for collecting the evidences. So these people have different jobs. Okay. So gentlemen, this, as I said, that this security onion has many parts or very many components. One of the component is ELK suite. ELK suite, where ELK stands for the elastic search. E stands for elastic search. L stands for log stack, and K stands for Kibana. So we will be using these three things when we will be installing the security onion. When we will be installing the security onion, we will have the ELK, and we will be doing a lot of practice on it. So basically at that time, आप क्या कर रहे होंगे? What will be your job? Your job will be to understand how SIEM works and what are the functionalities of this SIEM. So as I said to you earlier, that the one of the proprietary solution is SolarWind, which is a security event manager, and the other one is the Splunk Enterprise Security. So these are the two. SolarWind and Splunk are the two important SIEM solutions which are used in the SOC. But Security Onion and ELK is again quite a modern tool. So we are equally good if we study the ELK. Okay, already we have done this logging network activity. We have done we have last week we already have the video as well. We created an FTP session, and through this FTP session we sniffed this FTP traffic and in a sniffer. Furthermore, we use the syslog messages. We collected them in a syslog server. So we have already done this packet tracer logging network activity task. I hope you have seen it. And if you have not seen it yet, no problem. You have the on the weekend or even tomorrow or today, you can watch it. And if you have any question, I'll be happy to respond it. So this chapter number 15 is over. Gentlemen, we start with chapter number 16. Let's start. If you have, in the meantime, if you have any question, please do ask. Chapter number 16 is about the attacking. Chapter number 16 is about attacking. So in this chapter, basically, we will be talking about two layers. One is the IP layer, and the other one is which means the network layer, and the other one is the transport layer, which means the TCP. So we will be, may I say, we will be repeating the header of the TCP, which means the IP header, both the IP version 4 header and IP version 6 header. And then we will be talking about the TCP header and the UDP header. And then we will see that how the bad guy, which means the threat actor, uses these protocols, which means the layers, to attack. For example, IP spoofing, session hijacking, and many such attacks we will be talking about, which originates because of the network layer and the transport layer. Right, gentlemen? Do you got my point? So what is the objective of this chapter? As I said earlier, that I will be explaining you again, although I hope that you already understand what mean by IP version 4 and IP version 6, and what is the difference between the header of the two. What is in each header you must know what is the functionality, what is the syntax and semantic of these headers, which means, for example, what mean by the first 4 bits, what mean by the next 4 bits, what mean by the next 8 bits, for example. So it is very important, and how the threat actor uses these the same to attack, and how to respond then. So we that is the issue that we will be talking about the IP version 4 and IP version 6, and then gentlemen will be using it how IP vulnerabilities enable network attacks. Then we will be talking about the TCP and UDP vulnerabilities. First of all, before this, we will be talking about the TCP and UDP header structure, and then we will be saying that how TCP and UDP vulnerabilities enable network attacks. So very important, very interesting to know, to read it. So let's start. Like, so first of all, we talk about the IP protocol. You know, it is a connectionless protocol. Whether you are using IP version 4 or version 6, both are connectionless, right? And you know that multiple attacks can be done because of these IP. For example, ICMP attack, or man in the middle attack, or denial of service attack, or address spoofing attack. So there are numerous attacks, right? So we will be studying them in detail. What mean by, for example, by the ICMP attack, denial of service, distributed denial of service, address spoofing attacks, man in the middle attack, session hijacking attack, amplification and reflection and spoofing attacks. So we will be talking about all of these, but these attack uses the IP version 4 or IP version 6 headers, because all the traffic we know is using IP version 4 or IP version 6, or it is using either TCP or UDP. So, gentlemen, the person who has developed or invented these methods, he provided us with good faith that we'll be using it, and we'll be communicating with one another. But the bad guy looks at how it can be the same thing can be used in a bad way, which we call is the weakness in the protocol, which we call as the vulnerabilities. So we'll be talking about this. So IP was designed as a layer 3 connectionless protocol. We know why it is called connectionless, because the IP does not make a connection before sending the data. It is, as I said to you earlier, it is like a post office. In the post office, you put your letter and you hope that it will reach, but you never first talk to the person that I am sending you this letter. This is your address. Please confirm whether you want to receive my packet or not. You want to receive my letter or not. No, like this. So IP was designed as a layer 3 connectionless protocol. It provides the necessary functions to deliver the packet from the source to the destination, right? IP makes no effort to validate whether the source IP contained in the packet actually came from that same source. IP never ask. मिसाल के तौर पे अगर आप अपना you are sending your, for example, you are sending your letter and you are writing your own address wrong. Post office never ask you have written your address wrong. or you have written your name wrong, or you have written your city address wrong, street address wrong, home address wrong. No. So IP is very much similar. IP never says to you that, okay, you are sending this IP, you are sending this packet with this IP, and this IP doesn't belong to you. No. So you can craft the packets with the wrong IP address. It is your choice. It is called IP spoofing, right? So for this reason, threat actor can send packets using a spoof source IP address. You may be using the IP address of anybody else, maybe the server in your network. So it is spoofed. So this becomes an attack. You can attack like this, for example, and the word will feel that the other machine is sending these packet. However, you are sending on behalf of this machine. So also threat actors can change with the other fields in the IP header. So in a minute, I will discuss with you what are the fields in the IP version 4 header and what are the fields in the IP version 6 header, and then how the threat actor can use these fields to make the attacks, to launch the attacks. So it is important for the security analyst to understand the different fields in both IP version 4 and IP version 6 headers. So here is, gentlemen, the IP version 4 header. So you can see that the first 4 bits represents the header type, IP version 4 type. Either it will be written as 4 in binary or 6 in binary. Okay. Then is, gentlemen, the next 4 bits represents the header length. And you know, in the 4 bits, we can represent from 0 to 5, 0 to 50. So that the length of this header is 5, which means 20 bytes. As you can see here, 20 bytes are 5 words. 1 word, second word, third word, fourth word, and fifth word. So the minimum is 5, and you can see that is something good. Please take a, for example, you can take a you can do the print screen so that you have this picture with you, and then I can show you the packet here, which is the real packet in the IP. Here you can see, gentlemen, it is IP version 4, which is equivalent to 0100. I hope you understand. You have all done this DLD task. You can convert this 0100 and it represents the header version, the IP version. Then is the, after this version is the header length, 20 bytes, 5 words, either 20 bytes or 5 words. Then after this header length, what you have, gentlemen? What you have, gentlemen? If I can show you here, is the differentiated services, which is the second byte. So you can see here the differentiated services. Among the differentiated services, the first 6 bits represent the DSCP, which is the differentiated services code point, CP. So you can see here differentiated services field. And the last 2 bits are the ECN, explicit congestion notification. After this, gentlemen, you can see the total length. Total length 500. This packet is of 578 bytes. Total length. Total length includes the header length as well as the payload. So the 20 bytes are of the 20 bytes are of the header. So, and 878 will mean 858 bytes are of the payload. Then after the total length, we have the identification. So the identification number is 0x5CD3. So this is the identification. Then is the flag. Then is the flag. So I will explain to you what means the flag. Do remember, gentlemen, that this whole word, the second word, is about the fragmentation. And why we do the fragmentation? I just give you an example. But for the before this, I want to show you that exactly this header is implemented. So this is not only the theoretic something theory, it is practical. So after this, we have the fragment offset 0, time to live 64, protocol 6 number here. 6 means that above this IP, the protocol to which this data will be given is a TCP, not UDP, not ICMP. So this is the protocol. Then is the header checksum. So here is the header checksum. Then is the source address and destination IP address. So gentlemen, you have seen here exactly the TCP header. Do you understand everything now? That what we are studying is not the something gossip, it is the reality. So version means that whether tells whether this packet belongs to IP version 4 or IP version 6. Internet header length, how many, it is 5 bytes, sorry, 20 bytes or 24 bytes or 28 bytes and so on. So it can be, as you can see here, from 5 bytes up to 15 bytes. So not bytes, words. 5 words up to 15. Because in 4 bits, you can have from 0 to 15. Then this is used for the DSCP, is used to provide some quality of service. But it depends, because you may be using DSCP. It is not important or it is not essential that all the routers on the route will be following the same DSCP. That's the reason it is not so much stronger method to represent the quality of service. But in the standards, this method is available. Then is the congestion notification, explicit congestion notification. If your buffer is filling, so what is the response? What I should do? I should tell my the node which is sending me data to slow down, because if it doesn't slow, my buffer will be full and further packet will be dropped. So to remove this phenomenon is called congestion. So these last 2 bits are used for the explicit congestion control. Then is the total length, as I said earlier, it is the length of the payload as well as the header. Then this complete word is about the fragmenting the packet. For example, you know that the total length is in 16 bits, and 2 power 16 is 65,535. If you take the calculator, for example, gentlemen, here is the calculator, and you go to the programming calculator, for example, instead of the scientific, and you gave, even not essential, I can use the standard scientific one, 2 power xy 16. So you can see, gentlemen, it is equal to 65,500. So the maximum total length can be 65,000, but none of the technology at the layer 2 support such a big packets. For example, if it is Ethernet, it supports up to 1500 bytes. However, when you are on 10 gigabit or 40 gigabit packets, technology, then you can have the jumbo frames which are bigger than 1500 bytes. So, but on the way, for example, your incoming is a 10 gigabit Ethernet, or maybe tomorrow it may be 40 gigabit Ethernet. So, gentlemen, your next may be a point-to-point link, and probably this link is supporting, let it assume, 1000 bytes. So your packet is of, for example, 200 bytes, 2000 bytes, 2000 bytes. but your next hop supporting only 500 bytes. So you need to make this big packet small packets. This phenomenon is called fragmentation. So this fragmentation is done by this layer, because again, if the packet is fragmented, these packets need to be combined together by the end device. By the end device, I repeat, not by the intermediate devices. Fragmentation is done by the intermediate devices, but the packets are recombined at the end device. How it will do it? By using this information. Then is the time to live. So the packet may not be forever in the loop. So it is the time to live. Protocol tells what upper protocol is being used. Whether, for example, you are using the TCP or UDP or ICMP. So here is the protocol number shows that. In the example just I gave you, I was using the number 6. So 6 means TCP. If you have the UDP, it will be 17. Let's see this as well, gentlemen. It is all TCP. It is all TCP because I'm using HTTP. So I have to open the next again to show you UDP as well. DNS is using UDP. Okay. And UDP, DNS, yeah. And DNS is using, you can see here UDP. And if you are using a UDP, what is written in the protocol field? 17. So when this 17 represents in the IP, because this is the IP protocol. So this is representing 17 is representing that the from above the IP you have the UDP, right? Yes, this is DNS. I don't have the ICMP packets. For example, if I use the ping, no, I don't have the ping. Ping is using ICMP. Okay, Muhammad Ali and Tabish, let's move further. So you understood what I mean by this header checksum. Only the header need to be verified that nothing has changed. So this is use the header checksum, 16 bits. And finally is the source address and destination address. So do you got everything about the IP header, or you have any question? So I explained to you everything: version, internet header length, differentiated services, total length, all these fields I explained to you. Identification, flag, fragment offset, time to live, protocol. If you are using, as I give you the example, TCP uses 6 number, UDP 17, ICMP 1. So these number represents which protocol is being used. Checksum, source address, destination address, and if something further is required, then you can put it in the options. Then, gentlemen, the next version is IP version 6. Because we have already studied this in our module 1, which is Introduction to Networks. So, gentlemen, here we have the what has been done here, and I have in the IP on the Facebook. If you remember, I few months back I uploaded in the photos. Probably it might be here. TCP and UDP. No, IP version 4 and IP version 6. It was a very nice comparison of the two. Yeah, here it is. So here is the comparison, that which this yellow means, sorry, blue, yellow. Yellow means that the same fields are used here. Like for example, version is here, source address here, destination address here. The red one is mean fields not kept in IP version 6, like identification, flags, fragmented offset, header checksum. These fields are ignored. No option, no padding, no internet header length, because this is fixed length and it has the options. That's the reason the header length was important here. No header length is here. The name and position changed is of this color. For example, you can see the name is changed. Type of service or DSCP, the name has changed to traffic class. Here it is the payload length. Here we will calling it the total length. Now we call it the payload length. Here we will be calling as the protocol. Now we call it the next header. Similar thing. Here we call it a time to live. Here we call it a hop limit. So that is these are the only the name changed. And this is the newer one, flow label, to provide better quality to specific flows. Does it make sense, gentlemen? Very nice figure to explain the compare the IP version 4 header with the IP version 6 header. Do you have any question, gentlemen? Muhammad Ali? So up to this we have covered. Tomorrow we will be covering the vulnerabilities, which means the weaknesses. Probably you might think about this today, that you have read about the IP version 4 header, IP version 6 header. What can be the weaknesses in these protocol, which the threat actor use to launch the attacks? So it is a something to think about. And tomorrow we will be talking about all of these, inshallah, on Friday. Does it make sense, Ali and Muhammad Ali and Tabish?
Yes, sir.
Yes, very right. You said Cisco Telos. It is the intelligence, uh, threat intelligence system of Cisco. Cisco Telos. Very nice, Tavish. So see you inshallah tomorrow. In the meantime, I should stop this recording